Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 10.4, Factoring to Solve Quadratics, Day 2. So everything today should be reviewed for you from the last two videos that you watched. Okay? That top row, roots, solutions, zeros, and x-intercepts, all that is saying is that all of those words mean the same thing. Again, roots are what we find when we take the square root of something. Zeros are what we find when we factor, and x-intercepts are what we find when we graph. Okay? So quick review on solving by square roots. If I take the square root of a positive number, I'm going to get 2 solutions. If I take the square root of a negative number, I'm going to get no solutions. And if I take the square root of a 0, I'm going to get 1 solution. Now, it is important to know when you're going to use square roots versus when you need to factor. One main way to figure that out is if I only have ax squared plus c. If I do not have that middle x term, so an example of that would be this example 1 down here. I have 4x squared minus 1 equals 15. There is no x to the first power term there. An example of what I'm talking about x to the first power would be here. I have x squared minus 5x. I have 2x squared plus 4x minus 70. Those are examples of having the bx term, the x to the first power. So when I do not have that, I can look into trying to solve by square roots. So example 1, what would I do first? I'm going to go ahead and add 1 to both sides. I'm left with 4x squared equals 16. I can divide by 4. X squared equals 4. At this point, I can take the square root of both sides. So x equals. Remember, anytime that you take the square root of a positive number, I'm going to need plus or minus. So the answer is x equals plus or minus 2. On to example 2. I have x squared minus 6 equals negative 6. If I add 6 to both sides, I'm left with x squared equals 0, because negative 6 plus 6 is 0. I can take the square root. X then would equal 0. The reason why I do not need plus or minus when my answer is 0 is because 0 cannot be positive or negative. The final example, example 3, subtract 5 from both sides. X squared then equals negative 25. I can try to take the square root, but we do not have anything that is the square root of a negative, so this would be no solution at this point. Again, there is imaginary numbers, but we're not getting into that right now, so we're just going to say no solution. All right. On to the zero property. Now, this was from your last video. Reminder what the zero property says. It says if a times b equals 0, then a or b has to equal 0, meaning I can just make one of them equal to 0, or I could set both of them equal to 0. So solve each equation by factoring using the zero property. We're going to do a factoring review and zero property. First thing is we're looking for a GCF. So what does x squared and negative 5x have in common? They have the x term. So I take x times x minus 5 equals 0. Since I'm multiplying those two things together, and that multiplication problem equals 0, I can set the x equal to 0, and I can set x minus 5 equal to 0. Well, x equals 0 is done. Here I just have to add 5 to both sides. So my two answers are x equals 0 and x equals 5. Again, I want to work with the GCF. So what is common between 4x and 16? Well, 4x and 16 are both divisible by 4, leaving me with x plus 4 inside the parentheses. I can set the 4 equal to 0. I can set the x plus 4 equal to 0 using the zero property. Subtract 4 from both sides. X equals negative 4 is one of my answers. 4 does not equal 0, so I'm just done. Now remember, the degree, the highest degree, or the highest exponent, I'm sorry, is going to tell you how many answers you're going to have. So in this case, I had 2 answers. In this case, my highest exponent was 1, and I just had 1 answer. Okay? Find the roots. Remember, the equation must be equal to 0. Don't forget the first question of factoring. Is there anything in common? Every single one of these has at least two different x terms in it. So I cannot use square roots on these problems right now. What I'm going to look to do is find a GCF. So what's common between x to the third and 14x squared? That would be x squared. There's 2 x's involved in each one of them. X to the third divided by x squared is just x. Negative 14x squared divided by x squared is negative 14. Now I can use the 0 property. X squared equals 0. X minus 14 equals 0. If I take the square root, x equals 0. If I add 14, x equals 14. There we go. Now, some of you may ask, I just said that the degree tells me how many solutions I should have. So I should have 3. Well, technically, I have 2 0 answers there. That's why it doesn't look like I have 3 answers, but I really do. Because 2 of them came from x squared equals 0. That's really 0 twice. Okay? On to B. First thing I want to look for, is there something in common with all 3 terms? I'm not worried about the equal 0 side of it yet. I'm just looking at those 3 terms to see if there's something in common. Well, all of those are even numbers, which means they can all be divided by 2. Leaving me with x squared plus 2x minus 35, and that will equal 0. I just have to bring my equal 0 along until I am ready to use it. Now, the 2 out front, there's nothing I can do with that, but x squared plus 2x minus 35, there is something I can do with that. We're going to factor. So I need to make a factor tree of both my a term and my c term. So to multiply to 35, I have 1 times 35 and 5 times 7. I have a negative in the back, so I want to multiply to something larger than 4. I'm going to take x times 5 then, because 5 is close to 4. So x times 5 is 5x. X, I have to use x. Because I used 5, I have to use 7. How can I make 7x and 5x be a positive 2? To make them a positive 2, I would have to make my 5 negative. So the 2, which is my GCF, just has to come along. Make my 2 sets of parentheses equal to 0. X is going front. And because I just have x's, it does not matter where I put my 7 or my negative 5. I could have flipped those if I wanted to. Now I have 3 things I need to set equal to 0. So 2 equals 0, x plus 7 equals 0, x minus 5 equals 0. 2 does not equal 0, so I can cross it out. Subtract 7. I can add 5. Whoops. So my 2 solutions would be x equals negative 7 and x equals 5. On to C. Again, I have both of my terms have at least an x. So I'm going to look at what they have in common. In this case, it's just 1x. Leave me with x squared minus 100 equals 0. Now, there's a couple of options I can use from here. Since I have x squared minus 100 inside of the parentheses, that means that only one of those 2 terms has an x. I could use square roots there if I wanted to, but right now we're reviewing factoring. So I am going to use the other method, which is to factor using the difference of 2 squares. X squared is a perfect square, 100 is a perfect square. It is subtraction between. So I leave my x out front, which is my GCF. I make my 2 sets of parentheses. The square root of x squared is x. The square root of 100 is 10. One of them has to be positive. One of them has to be negative. At this point, all 3 of my terms, all 3 of my groups will be set equal to 0. So x is equal to 0, which is an answer. x plus 10 is equal to 0. X minus 10 is equal to 0. To solve these last two, I can subtract 10. So x equals negative 10. I can add 10, which means x equals positive 10. Now here is where I told you your degree, which is 3 in this case, will tell you how many solutions you're going to have. I have 1, 2, 3 solutions. I'm good to go. Okay? Let's move on to the back. Now, before I do anything, what I should do, especially when I have more than one x term, is I really want to get this set equal to 0 before I start. So I want to add this 36 over. Get x squared minus 12x plus 36 would equal 0. Okay? The same thing on the second one. Because 42 is on the right, I want to get it back to the left with my x squared term. So I have x squared plus x plus 42 equals 0. On F, it's already set up that way for me, so I'm actually all right on F. What I want to do now, then, is since I have an x squared and an x term, I have an x squared and an x term, I have an x squared and an x term, I'm stuck. I have to factor. I cannot use square roots here. So what I'm going to do is make my factor tree of x squared, make my factor tree of 36. 4 times 9, 6 times 6. Okay? Now remember, if that last term, that c term, is a perfect square, it's a good idea to try to use that first. So I'm going to take x times 6, which is 6x. I'm going to take x times 6, which is 6x. How do I make 6x and 6x into negative 12? Negative 6x, negative 6x. Negative 6, negative 6. One thing I do want to check before I continue is what is negative 6 times negative 6? Well, it is positive 36, which is what I need it to be. So now I can make my two sets of parentheses. Again, since I just have x in the front, it doesn't matter where I put my 6's. Now, I have the zero product property here. So I do have to set this equal to 0. Since I already have x minus 6 is equal to 0 here, I do not have to write it down again. I can just leave it one time. So x would equal positive 6. On to E. Again, I need to make my factor trees. X and x. 1 times 42. 2 times 26. No, that's not right. 2 times 21, I'm sorry. 3 times 14. And then 6 times 7. Now, I want to find something, because I have a positive in the back, I want to multiply to something that's smaller than 1. Because what would happen is, either both of my numbers would be positive or both of my numbers would be negative, and in that case, they would combine together to become larger. So I want to multiply by something that would get me to be smaller than 1x. The problem is I don't have anything that's smaller than 1x. So I have all these things that multiply to 42, but none of them can multiply to a positive 42 and add to a positive 1. Meaning that this is actually a prime polynomial. I cannot factor this. There's no way to multiply to a positive 42 and then add to a positive 1. On to F. On F, I need to make a factor tree of 3x squared. I need to make a factor tree of 2. I have a positive in the back, so I want to multiply to something that's smaller than 5, but is close to 5. So I'm going to take 3x times 1, which is 3x. Because I used 3x, I have to use x. Because I used 1, I have to use 2. That's supposed to be an equals. x times 2x is 2x. Well, how can I make 3x and 2x become negative 5? Become negative 5, they would both have to be negative. Negative 1 times negative 2 is positive 2, so I'm okay there. So I'm going to make my two sets of parentheses. Go ahead and put my x's in the front. At this point, I have to be careful. 3x has to multiply by negative 1. So negative 1 has to go in the opposite parenthesis. X has to multiply by negative 2. So that has to go in the opposite parenthesis. At this point, I have my zero product property. Set everything equal to 0. I can add 2. So 3x is equal to 2. Can divide by 3. X is equal to 2 over 3. Do not change that to decimals. The other one, I just have to add 1. And I'm done. All right, now that we've worked through some of our problems that are already set up for us, they're just factoring problems. Let's look at some story problems. So my story problem on my note sheet was a little bit different than what you guys had. So what I did is I just crossed that out. I wrote out the story problem that you guys had. Okay. So it says the sides of a square are all increased by 5 inches. So the first thing I want to do is I want to make a square that I do not know the side length of. Because I do not know the side length of it, all of the sides are going to be x. Because what we do know about a square is all of the sides are equal. Now, it says that I want to increase the side length by 5. So if I increase this side length by 5, it becomes x plus 5. Now, because that top side and the bottom side have to be equal, then I'm going to increase it in this direction as well by 5. Okay? Now, if I increase the right side down 5 to increase it by 5, the left side also has to go down 5 so that I keep them equal. Now I have a new box, a new square, that the sides of it are going to be x plus 5 all the way around. Okay? So, the sides of a square all increased by 5. That's what we just did with the green box. The area of the new square, which is this green box, this green square, the area is 196 square inches because, in order to get 196 square inches, what I have to do is I need to take one side, x plus 5, times another side, x plus 5. When you multiply two sides together, I get the area. Well, the area is 196. In order to figure this out now, what I need to do is I need to use double distribution. So I have x squared plus 5x. 5 times x is 5x. 5 times 5 is 25. That's all equal to 196. I need to combine like terms. So x squared plus 10x plus 25 equals 196. I need to set everything equal to 0, so I'll subtract 196 from both sides. So x squared plus 10x, 25 minus 196 is negative 171. Now, what you would do in this case is we would make a factor tree for x, which is x times x. I would make a factor tree for 171. I'm going to help you out a little bit here. 171, I have what you would normally do if you didn't know what multiply to 171 is take 171 divided by 2, which doesn't work. 171 divided by 3, so I have 3 and 57. 171 divided by 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 does work. I'm not going to keep going right now just because I don't want this video to last forever. So I'm going to tell you that what we're going to use, because I have a negative in the back, I need to have a number that is larger than 10, which is this 19. I'm going to go ahead and use 19. X times 19 is 19x. Because I used x, I have to use x. Because I used 19, I have to use 9. Now, how do I make 19x and 9x become 10x? The 9x has to be negative, which means my 9 has to be negative. Two sets of parentheses with x at the front. Does not matter where I put my numbers at this point because I just have x's. Okay? So what I can do now then is set my two different parentheses equal to 0. So subtract 19 from both sides. X equals negative 19. Add 9 to both sides. X equals 9. Now, we have to think about what x actually is. X is the original side length of our first square. So we're talking about length in inches. Can I have negative 19 inches? I don't think so. So I will not use x equals negative 19. I'm going to use x equals 9. So my answer is 9 inches. Will be my final answer. Okay? All right, let's move on to B. The product of two consecutive integers is 3 less than 5 times the smaller integer. So I'm going to have two integers. The smaller one is always x. That's going to be my smaller integer. Whoa, not writing anything. That's my smaller integer. Well, if I have consecutive integers, that would be like the numbers 2 and 3, 3 and 4, 4 and 5. I would take x and add 1 to it to become the larger integer. Okay, so it says the product of two consecutive integers. So I'm going to take x times my x plus 1, which is my larger integer. So the product means multiply, which is x times x plus 1. Is tells me I have an equal sign. 3 less than 5 times the smaller integer. So I'm going to do 5 times the smaller integer. Less than told me to start with 5 times the smaller and then work my way back to the 3. So less tells me to subtract, so it's 5x minus 3. Now what I'm going to do is distribute. So x squared plus x equals 5x minus 3. And like we said originally, when I have an x squared term and an x term, I have to set everything equal to 0. So I'm going to subtract 5x from both sides. So x squared minus 4x equals negative 3. Now I can add 3 to both sides. So x squared minus 4x plus 3 equals 0. At this point, I have to factor. So I'm going to make my factor tree of x squared and my factor tree of 3. Because the number, my c term, is positive, I want to multiply to a number smaller than 4. So I'm going to take x times 3, which is 3x. Because I used x, I have to use x. Because I used 3, I have to use 1. Now, how do I make 3x and 1x become negative 4x? They both have to be negative, which means the 3 and the 1 have to be negative. Now I can make my two sets of parentheses. All that's still equal to 0. X is going front. Because it's just x, I can put my negative 3 and negative 1 wherever I want. Now I can use the zero product property. Just add 3 to both sides. Now, what we've just found is the two different answers that our smaller integer could be. So our smaller integer could be 3, or our smaller integer could be 1. It does not matter in this case because we're just talking about integers. We're not talking about distance. On that last problem, we were talking about the length of something, so we couldn't use the negative. In this case, I don't have a negative anyway, so even in a problem like the one that we just did above, these would still work. So what this means is I actually have to have two different sets of integers. So my smaller integer would be 3. That's my smaller integer. If you look up here to the left, I have my smaller integer is x. My larger integer is taking x plus 1. So my larger integer in this group would be 4. Now I have a group where my smaller integer is 1. The larger integer could be 2. So I actually have two sets of consecutive integers that would work for this problem. Well, that is the end of our lesson. Make sure that if you have any questions, you come see me or you email me, and we can try to get those fixed. Otherwise, thank you very much for watching the video, and have a great day.